Hello everyone. Today we are going to discuss on the topic cubic root of 1. That is, we have to find out value of x whose cube is 1. Now see how can we determine these values of x. Suppose say cubic root of 1, suppose the value is x. Now if we cube both sides, we get x cube equal to 1. So you can easily understand this one is a cubic equation, and you know for any cubic equation it must have 3 roots. Now what are the 3 roots? Obviously you can check if you put here x equal to 1, then this will satisfy this equation. So 1 is obviously one of these roots. Now what are the other roots? For this, if we factorize them, what you will get x minus 1 x square plus x plus 1 equal to 0. And from here you will get either x minus 1 equal to 0 or x square plus x plus 1 equal to 0. And from here you get x equal to 1. And if you want to solution this equation, you see this is a quadratic equation. And how do you solution them? You cannot factorize them. So we will apply here Sridharacharya formula. That is x equal to minus b plus minus root over b square minus 4ac by 2a. And what will get here? Minus 1 plus minus root ca by 2. So clearly you can check here that these two roots are imaginary root. So when we solve this cubic equation, we get a real root. That one, our real root x equal to 1, and these two are imaginary root. So cubic root of 1, that is the value of x which satisfy the equation, there are 3 numbers. One is real, that is 1, and other two are imaginary. That one minus 1 plus minus root c by 2. Now if we write these roots, say minus 1 plus 3 root ci by 2 and minus 1 minus root ci by 2. Now if you make them square, if you square it, make them square, then what you will get here? 1 minus 3 minus 2 root ci by 4. And what is 1? This one minus 2 minus 2 root ci by 4. And if you cancel 2, you get minus 1 minus root ci by 2. That is the other root. That is, if you square one root, you will get another root. Similarly, if you square this root, you will get this root. That's why we denote this root by, suppose say this root we denote by omega. Then this one will be omega square. This root will be omega square. So we define this imaginary root by omega and omega square. If you take omega as minus 1 plus root ci by 2, then omega square will be minus 1 minus root ci by 2. If you take this one omega, then this one will be your omega square. That's why we write that cubic root of 1, its roots are, one is real root, that is 1, another two is omega and omega square, and they are imaginary root. So clear to everyone? So from this discussion, you can easily understand these imaginary roots, they are squared to each other. So this one is our first property. First property, the imaginary roots are squared to each other. That one you can easily understand from the previous discussion. Number 2, if you see the value of omega and omega square, omega equal to -1 plus root 3 I by 2 and omega square equal to -1 minus root 3 I by 2. So you can easily understand they are conjugate to each other. Here is the only difference is the signs are opposite of the imaginary part. So they are conjugate. So second, omega and omega square are conjugate to each other. Are conjugate to each other. That is, you can write omega bar equal to omega square or omega square bar equal to omega. So these two are very obvious property of the imaginary roots. Now come to the main points. Now our initial equation was x cube equal to 1, and solving this equation you get roots 1 omega and omega square. So obviously omega will satisfy this equation. So our number 3 property, omega cube equal to 1, that is the most powerful property of the cubic roots. That is, if you replace here x by omega, then you will get this relation. Now this relation has different explanation and different point of views. First of all, you can write this one 1 multiply omega square equal to 1. So what you will get here? You will get the product of the roots of cubic roots of unity. So product of the cubic roots of unity is 1. That is our first point. Product of roots is 1. Number 1. Number 2, you can write this omega cube as omega multiplied omega square equal to 1. So you can write here omega equal to 1 by omega square or omega square equal to 1 by omega. That is, when we are doing problem, we can replace 1 by omega square by omega or 1 by omega by omega square. Another point of view is they are reciprocal to each other. That is, omega means 1 by omega square and omega square means 1 by omega. So here omega and omega square are reciprocal to each other. So you can easily understand this one is our powerful rule of equation as a cubic root of unity, that is omega cube equal to 1. Now number 3 come power of omega power of omega is 3, then you get the result is 1. Now if you write here omega to the power 6, then what will get? Omega 3 square is equal to 1. That is, if the power of omega is a number which is multiple of 3, then it is obviously 1. So we can write here omega to the power 3k equal to 1. Now, no, sorry, you write in this way. You can write omega to the power n equal to 1 when n equal to 3k. That is, if you can write this n as a multiple of 3, then your result will be 1. Now, if this n equal to 3k plus 1, that is, if you if you can express this n in this form 3k plus 1, that is, when you divide the number by 3, you will get 1 as remainder. Then what will be your result? This one will be omega. And omega to the power n equal to when n can be written as 3k plus 2. This one will be omega square. That is, we can easily deduce any power of omega using this property of omega. If you divide a number by 3, then what you will get the remainder? Remainder will be either 0 or this case, or will be 1 in this case 3k plus 1, or will be 2. So what will be the value of n? You can easily deduce omega to the power n by 1 omega or omega square. Now come to the fourth point. We have calculated or we have got this omega from this equation x square plus x plus 1 equal to 0. By solving this one, we get root omega to omega square. So then obviously omega will satisfy this equation also. So number 4 point our, if you replace omega in this equation, you get 1 plus omega square equal to 0. This one is your second important property of omega. Now how can you visualize this? You see, this expression is the sum of the roots. That is, sum of the roots is 0. Sum of the roots is 0. That is your fourth property. And this one also very important on calculating problems on omega. We can replace 1 plus omega by minus omega square or omega plus omega square by minus 1. In this way, we can calculate the problems from omega very easily. So here also the sum of the roots of cubic unity is 0. Number 5. So our cubic root of unity, you get 1, you get omega, and you get omega square. And what is our omega? Omega means minus 1 plus root 3i by 2. And what is our omega square? Minus 1 minus root 3i by 2. You can write them as minus of plus root 3i by 2. And this one you can write minus half minus root 3i by 2. That is, I am writing this imaginary number as a plus ib form. A plus ib form. So if you take their modulus, what will be the value? 1 is a real number. You can write this one as 1 plus I 0 in this way. So modulus of 1 is obviously 1. Modulus of omega, if you calculate, this one will be 1 by 4, 3 by 4. So result will be 1. Modulus of omega square, this one also root over of 1 by 4 plus 3 by 4, and this one also 1. So our fifth property, you see, modulus of these three numbers is 1. I clean the board. Our fifth property, 1 omega and omega square, its modulus, they are 1. Now how can you visualize this property also? You know what is the modulus of a complex number meaning? Modulus of a complex number express distance of this point from the origin geometrically. So if you replace the value in eigenplane, if you replace the value, here will be your omega, here will be your 1 comma 0. Another point was minus half plus root 3 by 2. So here will be your omega, that one equal to, and here will be your omega square if you replace this point. And modulus of this 3 number is 1. That is distance of this 3 point from the origin, that is this distance, and this distance. All are equal. So you can easily draw a circle using this point. That is, cubic roots of unity lies on a circle whose center at the origin and whose radius is 1. So geometrically, this property means roots lies on a unit circle mod z equal to 1. Mod z equal to 1 means center 0 and radius equal to r. Radius equal to 1. So that is, this 1 omega and omega square lies on a circle whose center is at the origin and whose radius is 1. So clear to everyone? Now come to the sixth point. cubic root of 1, its result is 1 omega and omega square. Using this data, we can cube root of any number. That is, suppose you have to find out the cube root of say 27. So you can write, suppose the value is x. So 27 equal to x cube. And I can write x by 3 whole cube equal to say 1. That is, I 27 shift to the right side, you get x cube by 27, and x cube by 27 means x by 3 whole cube. This one will be 1. Now if you cube root both sides, this one x by 3 and this one will be cube root of 1. Then what should the value? Its value is 1 omega and omega square. So what is the value of x? X will be 3 omega or 3 omega square. That is, as cubic root of 1 is 1 omega and omega square, cubic root of any number will be its real value, that is the 3. If you find out the cubic root of 27, 27's cube root is 3. Then the other imaginary roots will be 3 omega and 3 omega square. Just multiply 3 by omega and omega square. Then you will easily get another 3 roots. Similarly, if suppose you have to find out cube root of say minus 27, how can you calculate them? You just check what is the real root of this value. That is, its real root is minus 3 only. So its root will be minus 3 omega, minus 3 omega square. That is, using this property, we can easily calculate cubic root of any real number. Just first calculate its real root and then multiply this real root by omega and omega square. You can easily get all 3 roots. Now the last point, last property. Number 7. When we draw this point on the argand plane, here will be our 1, here is our omega, and here will be our omega square. Now if you join them, you will get a triangle. Suppose I write here, suppose a P point, this one say Q point, and this one is R point. Now, what will be the nature of triangle? That is, we have just check the length of the sides of the triangle. That is, what will be the length of PQ, QR, and PR. You know what they mean actually? PQ means mod of 1 minus omega. This one means omega minus omega square, and this one means PR. PR means 1 minus omega square. 1 minus omega square. That is, we have to find out this value. I just checking only one value. Similarly, you can check. Suppose I find out say QR. So what our omega? Omega means minus of plus root ci by 2, and omega square means minus of minus root ci by 2. So we will check, this one will be root over of minus of plus of square plus root ci by 2 minus, the plus root ci by 2 square. Just take as from distance formula, just because they are obviously coordinate. This one 1 0, this one minus of plus root ci by 2, this one minus of minus root ci by 2. So they are only just coordinate. So just calculate the distance. What will be the value then? This one will be root 3 square. That is only root 3. And similarly, if you calculate all the value, you will get the value root 3. That is, length of all sides are equal, and its value what? Root 3. That is, they form an equilateral triangle in the argand plane. Cubic roots of unity, they are the vertices of an equilateral triangle in the argand plane. So this one is our 7th and the last property. So I think easily understand and visualize all the properties of cubic root of unity. And the third and the fourth rule, that is omega cube equal to 1 and 1 plus omega square equal to 0. They are the most important rule. on calculating problems. Other rules are just visualizing the omega square and 1 in the Argand plane, what they represent, what are the meaning. So I think it is now clear to everybody. Thank you.